Okay, beginning with 372. Please draw the diagram. Okay, it says to use what you know about the angles of a triangle to determine the value of x and the angles in each triangle below. So I know that the angles in a triangle sum to 180 degrees. So I'm going to set up an equation, x plus 90 degrees plus 79 degrees equals 180, and then just solve for x. So 90 plus 79 would be 169. Bring down 180, bring down your x, then I'm going to subtract 169 from each side. So this angle must be 11 degrees. Okay, part B. I see that these two angles are equal, which tells me this must be an isosceles triangle. When I have two angles that are equal in a triangle, or two sides that are equal, then it's an isosceles triangle. So I know these two sides must be equal, but we're just solving for the angle, so let's set up an equation. X plus 90 equals 180. So 2x plus 90 equals 180. Subtract 90 from each side. So 2x equals 90. And divide by 2 on each side. So x equals 45 degrees. So that's a 45, 45, 90 triangle. You'll see that again down the line. Okay, next one is also a right triangle. Looks like all of these are right triangles. Yes, I do expect you to draw the diagram. Okay, I'm going to write my equation. X plus 2x plus 90 equals 180. So that gives me 3x plus 90 equals 180. Subtract 90 from each side. So 3x equals 90. Divide by 3 on each side. So x equals 30. So this angle is 30. And this angle is 60. That's a 30, 60, 90 triangle. You'll also be seeing that again down the line. Okay, so this is like part A. We're just solving for the missing angle in a right triangle. And if this is 90 degrees, we know from the other two examples, if you got a 90 degree angle here, then these two other angles, these two acute angles are going to add up to 90, right? Because we subtracted 90 from 180 in each case, and we got 90. So I'm going to skip this part right here and jump straight to x plus 22. I know these together are going to add up to 90. So x equals 68. Okay, 373. We are going to do probability a little bit later in the unit. So I'm going to be doing a little more explaining on this one than I normally would do because we haven't done the lesson yet. And I might even do a little quick video on explaining some of these terms. There's some math notes in. Okay, give me a second. Let me find where these math notes are. Okay, so there's some math notes on page 171, and that is in lesson 3.1.5. If you're looking at the ebook, that are very helpful. It has a definition for union, intersection, and some rules that you can use. I'm going to use just an example with all of the cards printed out. So first question says, in a standard deck of 52 playing cards, 13 cards are clubs. 3 of the clubs are face cards, the king, the queen, and the jack. Okay, so here's your deck of cards. You have 52 cards. You have king, queen, jack, and then you have ace through 10 for each suit. Each of these is considered a suit. Clubs, diamonds, hearts, and spades. So this said 13 are clubs. That's because if you look at each of the suits, you have 1 through 10, 11, 12, 13. So 13 are clubs, and 3 are face cards. So these 3 have a face. And then it says, what's the probability of drawing one card that is a club or a face card? So if I'm looking at clubs, there's 13 that are clubs. So part A, probability of drawing a club is 13 out of 52. Okay, and then it said, what's the probability of drawing a club or a face card? That word or is very important. Okay, so if I want to figure out probability of drawing a face card, well, there's 12 cards that have a face, a jack, king, or queen. So the probability of drawing a face card is 12 out of 52. Now, there's a few of those cards that are both. The king, the queen, and the jack of clubs, those are club cards, and they're face cards. So it said, what's the probability of drawing a club or a face card? Well, I don't want to count these twice. If I were to just add those two together, 13 plus 12, I would be counting the king, the queen, and the jack of clubs twice. And I only want to count them once. So you could literally sit here and just count these up. 13 plus 3 plus 3 plus 3. So that'd be 22. You could also use a formula to figure that out. So the probability of getting a club or a face card, and I want to show you this formula. Okay, if you're looking for a union, okay, this is from the math notes. The union of two events is the event in which the first event, so club, or the second event, face, or both occur. So the union of the events 2, 3, 5, and 7, and 2, 4, 6, 8, and 10 is 2, 3, 4. So you see how we're not only counting 2 once. 2, 3, 4, 5, 6, 7, 8, and 10. So there's a formula that you can use for the probability of the union of two events, probability of A or B. So probability of a club card or a face card is the probability of A, the club card, plus the probability of B, the face card, minus the probability of both of them, A and B, club and face. Now you may say, oh, this is easy enough to do, I don't need a formula, but some people like to know this. So that would be 13 over 52 plus 12 over 52 minus the 3 that were the intersection of those, so minus 3 over 52. 13 over 52 plus 12 over 52 is 25 over 52 minus 3 over 52. Remember, when the denominator is the same, We don't need to worry about anything, just add or subtract our numerators. So our final answer is 22 over 52. Okay, for part B, it says probability, and this is the way you write it, if you didn't know, of club and a face card. We basically already figured this out. The only cards that are both club and face are these three cards right here. The Jack, the King, Queen, and the King of Clubs. So 3 out of 52. That is considered an intersection of two events. So if you see the word intersection come up, it's the event in which both the first event and the second event occur. So club and face. So the intersection of 2, 3, 5, 7 and 2, 4, 6, 8, 10 is 2. That's the only one that's in both events. These are prime, these are even. So prime, probability of getting a prime number and both prime and even out of these two sets of numbers would just be 2. Okay. Last question says, okay, so that was an intersection. The last one was a union. I didn't write that on the paper, but part A is a union, part B is an intersection, part C, not a club, not a face card. Okay, well, again, this is one, if you have the visual, some people are going to say, I'll just count them up. That's fine. So not a club, so none of these, and not a face card. Well, that's just going to be 1 through 10 times 3. That's going to be 30 out of 52. So for C, not, let's see, this last one was intersection. So not a club. Let's see if this is a little bit better. It was better before. So not a club or a face card would just be your total. So the probability of choosing any card would be 52 out of 52 minus the answer that we got from part A, which was 22 out of 52. So probability of choosing any card minus the probability of club or face. Here's the probability of choosing any card, 52 out of 52, and our answer from part A was 22 out of 52. And that's what we did with the visual. We just said, okay, it's everything except all of these and all of these. So that leaves me with 30. But if you wanted to do it without the visual, you could just say all of them minus club or face would leave you with 30 out of 52. Okay. 374, solve for the missing lengths. So I have, I'm going to say we don't have to draw these, but I do want you to write that statement. Triangle ABC is similar to triangle OPQ. We didn't get as much practice with this as I would have liked. We had to stay on schedule, but I'm going to take this statement. Now some of you are going to say, I don't need to do it that way. That's fine, but I always like to check in case they're trying to throw me a curveball. It looks like CB corresponds to QP. So I'm going to look at my statement and I see CB, the last two letters here, match up with PQ. So it is correct that 4 corresponds to 6 and that CA corresponds to QO, so it is kind of matching what it looks like, but I do encourage you to check that and be sure. So I'm going to write that proportion. I'm going to write out the letters. You can skip this part if you want. BC over QP. BC over QP is equal to AC over OQ. And then I'm just going to substitute the numbers. 4 over 6 equals 6 over the one that I'm solving for F. And now I'm just going to cross multiply, so that gives me 36 equals 4F, and divide both sides by 4, which gives me 9. Okay, same thing on this next one. I have a statement. Please write the statement. You don't have to draw the diagram unless you want to. Okay, now I'm looking at this picture and I see I'm looking for this side right here, GH. So I want to know, it looks like GH corresponds to UV, and in fact it does. GH is the third and fourth letter here, UV is the third and fourth letter here, EF is the first two. I see that that's 24, and it corresponds to the first two here, ST. So let's write that out. We've got GH, that's the one we're looking for, corresponding to UV. So I know whatever I divide those by, if these are similar, whatever this reduces to, all of the other corresponding sides should reduce to the same amount, because that's what similar means. It's just a dilation. One is an enlargement of the other. Okay, and then we have EF corresponds to ST. And remember, if I start with GH on top from this pentagon, I've got to start with aside from this pentagon for the next ratio. You can't mix them up. So GH, that's the one I'm solving for, over UV equals 24 over 20. I'm going to cross multiply. That gives me 20G equals, what's 15 times 24? 360. I should know that. Divide both sides by 20. So G equals 18. Okay. Last one like this, we've got JKLM is similar to WXYZ. Okay, I'm looking at the picture. Doesn't look like there's anything tricky going on here. Looks like 3 is going to correspond to 10. 3 is ML. 10 is ZY. And yes, those do match up according to this statement. And then it looks like MJ, 7. MJ is going to correspond to WZ. So then 7 is going to correspond to H. Okay, if you want to skip this part, you can, but I'm going to write it out in case you need it. So I see ML corresponds to ZY. And by the way, you can change the quality of these videos if you're looking at them on YouTube. There's a little menu down at the bottom where you can change it. Let's see, what's next? MJ, last letter, first letter, is going to correspond to ZW. So that gives me 3 over 10 equals 7 over H. If I cross multiply, I get 70 equals 3H. divide by 3, I get h equals 70 over 3, and let's just leave it like that. Okay, part D, specify a sequence of transformations to map triangle ABC onto triangle OPQ. I keep saying I'm going to bring some tracing paper home, and then I forget to bring it, so I'm just going to grab and get a piece of paper. So if I was going to map ABC onto OPQ, I'm going to trace ABC and put the letters on there, because when you do this, if your vertices don't match up, you're stuck. You gotta figure something else out. Oh, and it didn't say this was a right angle. Okay. So I'm looking at this, I'm thinking we need to rotate it. So I'm gonna do a little XY axis, put my pencil at the origin. If I were to rotate it 90 degrees, I'm kind of visualizing an XY axis underneath. Okay, that would be a rotation of 90 degrees clockwise, and the letters are matching up. A matches with O, C matches with Q, and B matches with P, and that's what was asked for. Now, it still isn't mapped right onto this, so I would translate it up and left so that C is on top of Q, and then dilate it. I would dilate it with C as the center of dilation. That was well, I rotated it first. Let's say rotate 90 degrees. And then translate so that C prime we'll just say C prime corresponds to Q. That's a short way of saying it. And dilate, and the factor of dilation, if you look at the scale factor from part A, that scale factor was 4 over 6. And if we're considering, oops, I lost my spot. Here we go. If we're considering ABC to be the original, then it's getting bigger, not smaller. So scale factor, you have to think about which one's the original. Here they're saying map this triangle ABC onto OPQ, so they're considering this the original. So if this is going from 4 to 6, that's increasing by 1.5, 1.5, and you can see that in the scale factor right here. If I were to look at 6 divided by 4, that would be 3 over 2, which is 1.5. If you looked at it the other way, it would be 2 over 3. So the scale factor is there in one of your ratios. So I'm going to say dilate by 3 over 2, 1.5. Okay, 375. You should be a pro at multiplying polynomials. You see a lot of these on the homework if you've been doing them. Hopefully they're getting a little bit easier. I'm going to make an area model. And this is another thing, if you don't want to do it this way, that's okay. I'm probably going to use this a lot in class, so it will probably benefit you if you do learn how to do this and practice doing it this way. Multiply 2x times 3x is 6x squared. 2x times negative 2, negative 4x. 1 times 3x, 3x. Negative 2 times 1, negative 2. And if I'm going too fast, just pause the video. So then I'm looking at this. It says to write it as a product and as a sum. As a sum, it would be 6x squared these are alike. Negative 4 plus 3 is negative 1, so negative 1x minus 2. There's your sum. Product 2x plus 1, 3x minus 2. Okay, I'm going to go through these kind of fast. Oh, we've got a binomial and a trinomial. I think this is the first time you've had one like this on homework. So I'm going to make a 2 by 3 box. I'm going to put 2x and 1 on the side that has 2 squares, and then on the side that has 3 squares, put 3x squared minus 2x minus 5. So when I multiply these, I get 6x cubed. Okay, 3x squared times 1, 3x squared. Well, this is all just going to be the same as this, right? Because you're multiplying by 1. Negative 2x times 1 is negative 2x. Negative 5 times 1 is negative 5. 2x times negative 2x is negative 4x squared. 2x times negative 5, negative 10x. So as a sum, I'm going to have 6x cubed. There is no other x cubed term, so I don't need to worry about anything. I see 2 3x squared terms, negative 3x squared, negative 4x squared. If I combine those together, I get negative 1x squared. 3 and negative 4 is negative 1. I see negative 2x, negative 10x. Those are alike, so let's combine them. That's going to give me a negative 12x minus 5. There's the sum. The product would be 2x plus 1, 3x squared minus 2x minus 5. And I do expect you to write all of this out, show your work. There is one like this on the Chapter 3 test. So there's an easy one to get right. Hopefully. Okay, C. Binomial times a binomial, but we've got some x's and y's here that we haven't seen before. Now, it really doesn't matter if you put 3y minus 8 on the bottom or on the left. I'll try to be consistent and put the first one on the bottom, but it really doesn't matter. Negative x plus y on the side. So 3y times negative x is negative 3xy. 3y times y is 3y squared. Negative 8 times negative x is positive 8x. Negative 8 times y is negative 8y. Okay, I'm looking at this. I see no like terms, so we're not going to combine any terms. We're just going to have 3y squared minus 8y minus 3xy plus 8x. There's your sum. Your product, and there should be an equal sign here, is basically what you started with, 3y minus 8 times negative x plus y. Okay, part D. X minus 3y on the bottom, x plus 3y on the top. There's a pattern to these, so try to notice some things here. When we get to this, I believe it's in the next chapter, there's some nice patterns where you don't need to do this every time, and we'll make it go faster. So x times x, x squared, x times 3y, 3xy, negative 3y times x, negative 3xy, negative 3y times 3y, negative 9y squared. Now here, we do have some like terms. Those are alike. And guess what? They cancel each other out. Positive 3 and negative 3, when you're adding, equals 0. So those go away, and you're left with x squared minus 9y squared for your sum equals x minus 3y times x plus 3y. Okay, we're almost done. I do want you to draw the picture for 376. there is a question related to this on the test. It's not exactly the same as this. And we haven't looked at this for a little while, since chapter 1. Although I think you've had some homework problems like this. Okay, draw the picture, label all of those points on there. G. Okay, so looking at the diagram, John says that measure of angle BCF. So angle BCF, this angle right here, he says that that angle is equal to the measure of angle EFH. Do you agree? Why or why not? Well, we learned something back in chapter 1 that if we traced this angle right here and we translated it, slide it along the transversal, that if it matches up, then those are equal. And I'm using my piece of paper, but you could use a piece of paper at home. You could do the same thing. That worked, and I've kind of drawn it, and it does work, but it really only works for sure when these two lines are parallel. And we are not seeing any markings to say that these lines are parallel. They look like they're parallel, but we cannot make an assumption that they're parallel. So for A, no, they are not necessarily congruent. And it relates the answer for B. B says, Jim says you can't be sure those angles are equal. An important piece of information is missing from the diagram. So I would put no, we don't know that the lines are parallel. And then part B, what's missing is there are no markings. For parallel lines. And remember the marking for parallel, oops. Remember the marking for parallel lines would be, if they were parallel, you would have arrows. Okay, let me press pause while I get situated here. Okay, 377. Juan decided to test what would happen if he rotated an angle. So I'm just going to sketch an acute angle like the one we see on here, and I think I'll use a marker because I see it's going to involve a rotation, and my paper is not tracing paper, so in order to see through it, I'm going to use a marker. Okay, so he copied the angle at right on tracing paper and rotated it 180 degrees about the vertex. So in order to figure out where 180 degree rotation would be, I'm going to do a little XY axis on my paper. I'm not being completely precise, but if I draw perpendicular lines, one vertical, one horizontal, I should be okay. And let's see, let me put my paper like this. Okay, and he rotated 180 degrees. So you could just do this on the textbook if you're using a textbook, but you're probably using the ebook, so you might have to do all of this. Okay, so I'm going to put my X and Y axis on there. He rotated it 180 degrees about its vertex. This is the vertex. I should draw it in the original. This is the vertex of the angle, the point where the two rays of the angle meet. So I'm going to put my pencil on the vertex, the center of rotation, and rotate it. That would be 90. When the lines, the X and Y axis lines match up, another 180 degrees. It doesn't matter if you go clockwise or counterclockwise with 180. What type of angle pair did he create? Well, if you can see through your page, you will see that he created vertical angles. And remember, vertical angles are congruent. Okay, and then he rotated the same angle 180 degrees through a different point. Okay, so now he's rotating it through a point on this ray. Okay, I'm going to trace it again. Here's my XY axis. Here's my original angle. Here's the point that we are going to rotate. Oh, whoops. Okay, I'm going to pick this up and rotate it 180 degrees. There's 90 degrees. There's 180 degrees. I'm going to draw the original angle on there. Here's the original. So that would look like, use a marker, it would look like a Z. Okay, there was the original, the one that I traced, and then when I rotated it, I got, basically it kind of came right on top of the original for part of it, so that would be a Z shape.